Type 1. Prove the trigonometric identities. To solve such type of questions, we need to follow a few steps. First thing is you need to check in the question whether is any trigonometric identity applicable there, so apply that. Or if there is any trigonometric ratios to be changed, apply that. Second step is to solve the brackets. And third is look for the fractions. If there are some fractions involved, then take LCM. We'll just understand with these steps with the help of the question. So the question is 1 minus sine square theta into sec square theta is equals to 1. Now it's very clear that 1 minus sine square theta is an identity, right? So I'll just write the question again. 1 minus sine square theta into sec square theta is equals to 1. So I can replace 1 minus sine square theta as cos square theta, and I have sec square theta is equals to 1. Now I know that sec square theta is reciprocal of cos square theta, so I can replace that 1 upon cos square theta is equals to 1. Cos square theta cancels out, so we have 1 is equals to 1, that is LHS is equals to RHS. So we have proved that LHS is equals to RHS. Now we'll understand the same thing with the second question. Question is 1 upon 1 minus sine theta plus 1 upon 1 plus sine theta is equals to 2 sec square theta. Now the first thing we have to check is apply for trigonometric identities is applicable. But here we can see that there is no trigonometric identity applicable and neither any trigonometric ratios to be applied. No solve brackets, there is no bracket. So we come to the third point, and that is if there are some fractions involved, take LCM. So we are going to take the LCM. So we will have 1 upon 1 minus sine theta plus 1 upon 1 plus sine theta is equals to 2 sec square theta. Now when we take the LCM, we will have here 1 minus sine theta into 1 plus sine theta, and in the numerator you will have 1 plus sine theta plus 1 minus sine theta is equals to 2 sec square theta. Now this plus sine theta and minus sine theta cancels out, so we have 2 in the numerator, and in the denominator a minus b and a plus b, so it becomes a square minus b square. So we will have 1 minus sine square theta, and RHS is same. Now 1 minus sine square theta is cos square theta, so we have 2 upon cos square theta is equals to 2 sec square theta. Now it's clear that 1 upon cos square theta is sec square theta, so I can write it as 2 sec square theta is equals to 2 sec square theta. So again LHS is equals to RHS. This with the third question. The third question is under the root sec square theta plus cos square theta is equals to tan theta plus cot theta. So now again we are going to check for the trigonometric identities first. So it's clear that we can apply the trigonometric identities here, right? Sec square theta can be written as 1 plus tan square theta, and cos square theta can be written as 1 plus cot square theta. So I'll just write that. I'm taking the LHS only here. So when I replace sec square theta, I'll have 1 plus tan square theta and cos square as 1 plus cot square theta. Now when I'll open the bracket, I'll have tan square theta plus cot square theta plus 2. Now we know that tan theta into cot theta is equals to 1. So here 2 can be written as 2 into 1. So this 1 I'm going to replace with tan theta plus cot theta. So I'll have tan square theta plus cot square theta plus 2 tan theta cot theta. Now it's clear that this has turned into an algebraic identity, a square plus b squared plus 2ab. So I can write it as tan theta plus cot theta whole square. So this square can be removed with the help of the square root. So I'll have tan theta plus cot theta, and which is RHS. So this is equals to RHS.